So in this video, we are going to be dividing whole numbers. Um, we're going to start off with modeling this division using the set model. It's also called the partition model, also the missing factor model, and repeated subtraction. So when you think of a set model, it's also called division by sharing, okay? I want you to think of playing cards. When you deal, if you're the dealer and you hand out the cards and you have three people there, each person gets one card, and then you go back and give everyone a second card, go back and give everybody a third card until you've dealt out all your cards. So same thing with cookies. We're going to deal out our cookies. We've got 18 cookies. We got three people. So we're going to give Bob a cookie, Dean a cookie, Charlie a cookie. Go back and give Bob another cookie, Dean a cookie, and Charlie a cookie until we run out of cookies. And at the end, we look and see how many cookies each person has. And each person got 6 cookies. So that's called the set model or partition model or division by sharing. Just depends on which book you're teaching out of. Okay. The next one is called the missing factor model. So if students really know their multiplication facts, they are going to do really well with the missing factor model. So the missing factor model really relies on those fact families, that we talked about. So if they remembered that 18 is 3 times 6, then they can quickly find out the answer to this one, because 3 times what is going to give me 18, and that's going to give me my 6 right there. So if they know their fact families or number bonds, the missing factor model will be really easy for them. If they don't have their multiplication facts memorized, then the missing factor is pretty hard, okay? So repeated subtraction, we're going back to cookies again. We have 18 cookies and we want to put them in a package of 6 to a box. So we're going to box them up, and we want to know how many boxes we need. So we're going to literally subtract, right? We're going to subtract 6. We got 18 cookies. We subtract 6 and put it in the first box. Now we got 12 cookies left. So out of the 12, we take 6 away. Now we have 6 left, and then we took those 6 away. So we had 3 boxes of cookies, okay? Near Easter, we got 12 Cadbury eggs, and we're going to get them in sets of 3. That's how you buy Cadbury eggs, unless you're getting them at Sam's or Costco's. Anyway, so how many packages do we have? So you had your 12, you took 3 out, that's one package. Then you took another, so you had 9. You took 3 more out. So now we have 6. We took 3 more, another package. Now we have 3 left. And then we took 3 more and put it in a package. So how many packages do we have? We got 4 packages of Cadbury eggs. Okay, so that's called repeated subtraction. So now let's talk about a division algorithm. What is an algorithm? Algorithm is just that step-by-step procedure for doing something, for solving a problem or doing a calculation or computation. Okay, so this is the way I was taught long division. Okay, and it was just a big long list, old school method, like 7 steps, and I walked in and it was on the board, and I looked at the board and thought, I'm never going to learn this. This is going to be too hard. Okay, but we can show them how that big long division model works. Okay, so first thing we're going to do is we want to separate 32 into 6 equal parts. So we have these apples, and we're going to separate them into boxes, right? So we got 1, 2, 3, 4, 5, 6 boxes. So we can separate them again, just like we're dealing cards, and put an apple in each box, and then come back and put another apple in each box until we're done. How many do we have in each of our boxes? Notice we have 5 apples. We have 5 apples in each box, okay? So how many are in each part? We've got 5. And then how many are left over? We have 2 left over, okay? So let's look at how we could do that using our algorithm, okay? So we're saying 6 goes into 32 5 times, okay? And then 5 times my 6 gives me that 30. And then we subtract, we got 2 left over, okay? So, so the 6 is called the divisor. That's what you're dividing by. The 5 is called the quotient. A lot of people say that's your answer, okay? The quotient. But you also have this remainder there. That's your remainder. So how many are in each part? 5 are in each part. What is left over? Your remainder is 2. Okay, so you can write this 6 times 5. That would give me my 30. And then we have 2 left over. Okay, so this division algorithm gets a little bit geeky. Okay, it says given any whole number A and B. Okay, so that means these numbers are whole numbers that we're talking about. Where B isn't 0, because we can't divide by 0, there exists a unique whole number, Q, which is the quotient, and the remainder, R, such that A equals B times Q plus R. What in the world? Where R is between 0 and B. What in the world is that saying? Okay, so that's saying that 5 times, that's saying that 5 times my 6 is going to give me that 30, and then we have this remainder. This part means this remainder cannot be more than this 6, right? So if I had put 4 up there and I got 24 when I subtracted, I would have gotten a number bigger than 6, which means, now wait a minute, I could put more apples in there. Okay, so I hadn't dealt out all my apples. So if your remainder is bigger, if this remainder is bigger than your divisor, then you've got to go up on that number. Okay. All right, let's talk about division by 0 and division by 1. First thing is, what is the answer to 0 divided by 12? Well, I like to think of pizzas. If I have 0 pizza, I don't have any pizza, and I have 12 people, how much pizza are we going to eat? We're going to eat nothing. We're not going to eat any pizza, okay? But it is okay to have a 0 on top, because we could go ahead and eat tacos. We might have a taco party instead of a pizza party, okay? But we're eating 0 pizza, okay? But this should be illegal. What if you have 12 pizzas sitting there and no people? Shouldn't that be illegal? To have 12 pizzas that's just sitting there and nobody's eating them, that should be illegal. So that's why no, you cannot have a 0 on the bottom. You cannot divide by 0, okay? It's called undefined. That's the word. You don't say can't do it. You say undefined. All right? Okay. So now we've talked about adding, subtracting, multiplying, dividing. Let's see how all these are related. Okay? We already knew that adding and subtracting undoes each other. If I give you $5, the way I undo that is I subtract the $5. I take the $5 away. Okay. And we also knew that multiplication and division undid each other. If I multiply by 5, the way I could undo that is to divide by 5. So those are inverses of each other. And we talked about that a lot. But what you might not realize is that addition is related to multiplication. Okay, and that is one way that you can teach multiplication. You can start adding numbers and say 3 times 5. You add 3 plus 3 plus 3 plus 3 plus 3, and you do that so much, one of your kids in your class is going to say, now wait a minute, we could just multiply 3 times 5 and that's going to give me 15. It's a shortcut. Okay, so it really helps if you get your students to realize that multiplication is just a shortcut for adding a whole lot of numbers. Okay, also subtraction. If you subtract, repeated subtraction is related to division, just like repeated multiplication is related to repeated addition is related to multiplication. Okay, just thought that's a really great concept to understand the relationships between adding and subtracting, multiplying and dividing, and also the relationship between adding and multiplying, subtraction and division. Okay, so now that we've learned all those, of course, we're going to put them all together. Okay, so you've probably heard of Please Excuse My Dear Aunt Sally, um, or you might have heard it as PEMDAS. We hear it different ways. So please stands for your parentheses. So you do whatever is in parentheses first. Then you do any exponents that you have. Then you do multiplication. Then you do division. But that multiplication and division is left to right. And that is where lots of students mess up, is that left to right, because people like multiplication, not division so much. So they want to do all the multiplication first because it's easier, but it has to be left to right. Okay? Adding and subtracting. Now we say that it's left to right, but eventually when we get to chapter 5, where we have positive and negative numbers, um, once you start putting negative numbers in there, then this left to right goes away. Okay, and we'll talk about that once we get to chapter 5. But for right now, just think left and right. We're going to add and subtract left to right as well. Okay, so let's do some examples. So the first thing we're going to start off with is we're going to multiply those guys together. Not multiply, but subtract those guys because they're parentheses, right? So we're going to subtract those guys. So we're going to get a 4 there. When you are working these problems, you need to absolutely continue writing these things down. Okay, don't just put like a 4 up on top and then keep going. Okay, it starts getting confusing. Okay, so then what our choices are: multiplication, we could multiply, or we could add, and it's multiplication and division goes first. So we're going to multiply that 4 times 4 and get 16, and then add our 2 and get our 18. Okay, most students don't miss that at this. Usually in my class now, in your classes, they probably will. Okay, but in this class, that's not what most people miss. It's this next problem. Okay, and it's because people want to do the easiest thing first, and they see 6 plus 2, and they're like, "Oh, that's 8. Let me do that. Let's do that and get it out of the way." Okay, but that is not what you're supposed to do first, right? You're supposed to do your parentheses first. So let's do our parentheses first. So this is going to turn into 2, right? 5 minus 3. Once again, it's so tempting to do 6 plus 2 because it's 8. We know it. Let's do it first. But no, we got to do our multiplication first. So it's going to be 6 plus 4. That's going to give me 10. All right. All right. Next one. Let's do our parentheses first. Okay. And I think that I did 2 steps in one. Okay. And you can have your students do that if that bothers you. You don't have to. But I've got parentheses and I knew I had multiplication as well. But you could have your students do parentheses in one step and then do the multiplication in the next step. And then finally do the addition and get 35. All right. Again, lots of folks go, "Oh, let's do this first. Let's do my 2 plus 3 first because I know that's 5." Okay, you've got to go in order. So I don't have any parentheses and I don't have any exponents. So when we're doing PEMDAS, And you could have your students do this. Okay, I didn't have any parentheses. I didn't have any exponents. So next I've got to do multiplication and division, but it has to be left to right, left to right. Okay, so a lot of students are going to say, oh, multiplication, 3 times 2 is 6. Okay, but that wasn't first, right? Our division was first. So we're going to do division first. So that gives me a 3. All right, so now our choices are subtraction, addition, or multiplication. So multiplication comes next. So that's how we got our 6 right there, right? We multiplied. All right, so now we have done multiplication and division left to right. All that's left is subtraction and addition. And it says left to right. So left would give me a 2. 8 minus 6 is 2. And then I add my 3 to get 5. Okay, so that one, go ahead and star it because that one is missed a whole lot on test, or one similar to that. I don't give you exactly the same thing, but anyway, okay. So once again, we do not have on this last one, we don't have parentheses, we don't have exponents. So next is multiplication and division, left to right. There's the one that's leftmost. So we're going to do that one first. So that gives me 4. All right. And once again, a lot of folks go, oh, I know the answer is 9. So they do that next, but we're not going to. And actually, some people do it up here too. They just love to do addition first because it's easy. But have to go in order. So 5 plus my 8, that gives me my 13. So you'll have several of these in class to work. And I'll have you work them individually and compare them to your partner because I want you to try and do it on your own and then figure out where your mistakes are because it's really easy to fall into these traps. Okay. So now let's talk about some division algorithms. We're going to use base 10 blocks. We're going to do partial quotients and we're going to do short division. Okay. So base 10 blocks. I'm going to show you how this works, and then have us work one out. Okay. So with this one, notice we're dividing 726 by 6. All right. So we're going to start. The key is we need to start. Don't start with these guys. Okay. Don't start with your little cubes. You're going to start with these big old blocks, okay, your blocks. So I'm going to determine, I'm trying to figure out how many 6s. So do I have 6 of these guys? So I do. So I'm going to take 6 of these, okay. So I know that I have 6 flats, right? So I've got 6 flats. So now, I've got my 6 flats, so I've divided it. So I've got 6 flats. So my flats, I have one set of 6 flats because I'm dividing it by 6. Okay, so I've got 6 flats. I've got one set of 6 flats. Now, when I look at these guys, I have this thing left. Okay, well, I'm going to break that into my rods. Okay, so that is 10 rods. So there they are. So this, that right there was that rod. Maybe I should highlight it. Let me do that. Oops. There we go. So this right here used to be this guy. Okay. So we've now broken it up. And so now let's see how many 6s we've got. 1, 2, 3, 4, 5, 6. So there's one set. And then 1, 2, 3, 4, 5, 6. Oh, I've got another set. So now I've got 2 sets. Oh, I'll write it down here since it's written. So now I've got 2 sets of 6 rods. And here's my 1 set of 6 flats. Last one, I've got 6 of those guys. So I now have 1 set of 6 units. So I have 1 set of flats, 2 sets of rods, and 1 set of cubes of my little units. So my answer is 121. I know, it's really weird. I know that's weird. So we're going to do another one, okay? So we're going to try using our blocks, okay? So let's draw our box, 524. So I've got 500, so that gives me 5 flats. I've got 20, so that's my 2 rods, and then I've got 4 units. All right, so I'm trying to separate these into groups or sets of 4. Okay, so notice right here, here's 1 set of 4. So that's 1 set of flats. 1 set of flats. All right. Well, I'm now going to have to take that other flat. Let's see, let's do it in green. This guy. Whoops, I meant to do it in green. Here we go. Let's try that again. All right. So I'm going to take this guy and I'm going to divide him into rods. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now I'm looking for groups of 4. So here's a group of 4. Let's see. Here's a group of 4. And, oh, look, if I get all those guys, there's a group of 4. So I've got 3 sets of my rods or longs, whatever you want to call it. 3 groups of 4, 3 sets of 4. And then, oh, look at this. There's 1 set of units. So what do I have? I've got 131. Okay. So remember, I started from the left. Okay. Should have told y'all that to begin with. I'm starting it from the left. Never start dividing at the units. We always start with the biggest. Okay. So let's do that one more time. So now I've got 462. Okay, so there's my 4 flats, my 6 rods, and my 3 units. What are my groups going to be? How am I going to set that up? So I'm going to have groups or sets of 3. So here we go. I'm going to start over here at the left. I've got 1 set of flats, 1 set of 3 flats. Once again, I've got to take this guy and separate it into 10. So, because that wasn't flat, which is 10 rods. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And now let's separate them into groups of 3. All right. So there's a group of 3. There's a group of 3. Let's come down here and group this up. There's a group of 3. There's a group of 3. And there's a group of 3. Holy moly, how many 3s do we have? So that's, let's see, I've got 1, 2, 3, 4, 5. So I've got 5 sets of rods or longs. Some people call them longs. Okay. Well, look, we have this lone rod sitting here. Okay, so that lone rod, we're going to have to split it up, right? So let's split it up. So I'm going to split it up into 10 units. I think that's 10. Yep, that's 10. So I took that rod and I broke it into units. Okay, And now, once again, we're looking for sets of 3. So let's see, there's a set of 3. There's a set of 3. There's a set of 3. Oh, and there's a set of 3. So we have 1, 2, 3, 4. We got 4 sets of units. So my answer is going to be 1, 5, 4. 154. Okay. That's sort of weird. So you'll probably need to do some practicing on that. Okay. All right. Super 7. This is one of those that my sister says is one of her students' favorite methods. Okay. So this is a way to represent the base 10 blocks algorithm. So we're going to start by determining what numbers we can subtract. Okay. So first thing we got to do is put these numbers in the right place. 524 divided by 4. Okay, so we've got 524, and we are going to divide it by 4. So we're going to put our 4 here. Okay, so that means we can break it up into sets of 4. So if we had 4, look up here, when we had here we got 4 here, okay? So we have 4 flats. Do you remember how many units are in one flat? It's a 10 by 10. So that's 100, and that's 100, and that's 100, and that's 100. So this one set of flats is 400, okay? These right here, when we're dividing these up, that's 4 rods. Well, that's 40, right? So that's 40. And then this is 4. So when you're dividing into groups of 4, here's your numbers to choose from. 4, 40, 400. If we had cubes, if we had if we had our cube over there, then, and we had 4 of them, that would be 4,000. Okay. So those are the numbers that we're going to be subtracting. Okay. Those are the only numbers that you can subtract when you are dividing by 4. When you're dividing by 3 over here, it's going to be 3, 30, 300, 3,000. Okay. So anyway, okay, so we want to start subtracting the biggest numbers that we can. Okay, so can I subtract 4,000 from 524? No, because I only have 524 rods, cubes, little cubes. So I don't have 4,000 of them. So I can't do that. Okay, but I can subtract 400. So I'm going to subtract 400. Oops, did not turn out too well. Okay, so I'm going to subtract my 400. Okay, and I'm going to be left with 124. So I had one set of 400. Okay, so next, and I already took that down, is I'm going to subtract 40 as many times as I can. So I subtracted it once and got 84. Then again, and I got 44. And then again, and I got 4. Okay, so how many of those did I subtract? I subtracted 3 of those flats, 3 of those sets of rods, excuse me. So I took off 3 40s. And then left, so I took off my 400s. Now I've subtracted my 40s. So now it's time to subtract my 4s. So when I subtract my 4s, I got 0. So I got all the way down to 0, and I had one set of units. So I now subtracted my 4. So my answer is going to be 131. 131. All right, let's do that one more time. because I know it's sort of a weird concept, okay? All right, so we've got 462, so that's going to go under my house. Okay, and let's determine what numbers we can subtract. Again, since we're doing groups of threes, sets of threes, that's going to be 30. Or we can have 3 rods. 3 rods is going to be 30. Or we could have 3 flats, which is going to be 300. We could have 3 of our cubes, which is 3,000. Okay. Now, we can't take away 3,000 because we don't have enough, right? Cross that out. So now we're going to start subtracting. We're going to subtract 300. So when I subtract 300, I can only do that once, right? I can only do that once. I don't have, because all I have left is 162. So I don't have 300 to subtract, okay? But I do have 30 to subtract. So I'm going to subtract 30 as many times as possible. So look how many times I subtracted 30. 1, 2, 3, 4, 5. So I subtracted 30 5 times. So that part is done. Okay. So now I've got 12 left after I subtracted 30 5 times. I've got 12 left. So that's why I can't subtract 30 anymore. I don't have enough. So now I'm going to subtract 3. And I'm going to subtract it. Let's see how many times I'm going to subtract it. 1, 2, 3, 4. So my answer, I'll do it in, I'll find the purple, but anyway, okay, so my final answer is 154, right? 154. Yeah. So again, my 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 sister's students absolutely love this because they don't like division. They don't like the hamburger method. That's what I call it, the old school method. They absolutely love this, and I call it the Super 7. That's my name for it because see how it makes a 7, big old long 7. So I call it the Super 7, but you can call it whatever you want. But it's called partial quotients. But your kids are not going to remember partial quotients probably. Anyway, okay. Just a little bit more to do, and we'll be done with this section. So, short division. Okay, this is a way to do the old school method, but it's a shortcut. Okay, so I'm going to go ahead and put the numbers where they go. 1,572 goes under the house. 3 goes on the outside. Okay, so the first thing I'm going to do is look at the very first number. 3 does not go into 1, but it goes into 15. So how many times? It goes in there 5 times. Do I have anything left over? No, it goes in there evenly. So I have nothing left over. So now I'm going to go to the next one. Let's look at the 7. 3 goes into 7 how many times? 2 times, because it's 6, right? And how many, when I subtract, how many would I have left over? 7 minus 6 is 1. And so I put that little 1 up there so it turns it into a 12. So now 3 goes into 12 how many times? 4 times, and I don't have any left over. So I don't have to do the big long this, let's go back up here. Ooh, way up here. I don't have to do this guy, right? I don't have to do that. Let me do that one short. Let's do that one using short division. See if it makes sense since we have it already here. So 6 goes into 32 how many times? Just 5 times, and it has 1. Well, that doesn't. Let me make something different. Let me do this. Let me have it go into 321. Okay, so 6 goes into 32 5 times. Does it have anything left over? Yes, we already said it had a 2 left over. right? So if I put my 2 there, I'd say 6 goes into 21 how many times? Let's see, I think it's 3, right? 3, that would give me 18. 18, 19, 20, 21, 22. 18, 19, 20, 21. So I have a remainder of 3. Okay, let's go down here and work some more, because that one's a little bit odd. Okay, so here we go. We've got 3,775 under the house divided by 5. So 5 goes into 37. Okay, it doesn't go into 3, but it does go into 37. Goes in there 7 times, and that gives me 35. So 37 minus 35 is 2. So I just put that little bitty 2 up there. So now I'm looking at how many times 5 goes into 27. And it goes in there, what, 5 times? Yep. And 27 minus 25 is 2, right? So I have a remainder. So I put the remainder there. Now I'll do the same thing. 5 goes into 25 how many times? 5 times. And this time I don't have a remainder. Okay, let's do it one more time. Again, you need to put 1, 11, 24 under the house. So 4 doesn't go into 1, but 4 does go into 11. 2 times. 4 times 2 is 8. So 11 minus 8 is 3. So that's where I got that little 3 right there. Now I'm going to say, how many times does 4 go into 32? So it goes into 32 8 times. Okay. Is there any remainder? No, 8 times 4 is 32. So I don't have any little bitty number to put here. Okay. And then 4 goes into 4 one time. So my answer is going to be 281. All right, last thing. And this one is estimating. Okay. When you estimate, that means you are not going to get the exact answer, right? So we're going to get something that's close. So instead of saying 52, we're estimating. So I'm just going to say, let's go into 50, right? Let's go into 50. So the 2 into 52, let's go into 50. And so it's going to be around 25. Okay. So now we're going to have 1672 divided by 4. Now, as a teacher, you may be have your students work this out in class, but have them work out the actual 1672 divided by 4. You want to have a ballpark. You don't know exactly what the answer is. You can figure it out because we now know short division. But they're doing this long division. And so you want to have a rough estimate of what the answer is. So instead of doing 1672, just do 1600, because 4 goes into 16 4 times, right? So the answer is going to be around 400. So when you have a student get 43 instead of 430 whatever, I don't know that that's what it is, but okay, that their place values off. They're getting their number. They're probably putting this number over here instead of over here. Okay. One last one. So instead of 128, I'm just going to do 120, because 3 goes into 12 4 times. So it's going to be roughly 40. Okay. And we are not going to divide in any other basis. So you are now finished with chapter 3.